Hi Year 4, welcome to Tuesday's math lesson. We are going to carry on with our equivalent fraction learning journey this week. And the first thing that I want you to do, just to get those maths brains warmed up, is have a look at these different representations here of fractions. And I want to know which representations of 4/5 are incorrect. So can you pause now? Have a little look at, there are 1, 2, 3, 4, 5 different representations. Have a look at each one and which ones are incorrect, which ones do not show 4/5. So pause now and then come back when you've had a go. How did you get on? Well, let's have a quick look. I can see my fraction here is 4/5, so that definitely shows me 4/5. If I look at this image here, where I've got 4 purple circles and 1 yellow one, we can see that the whole is 5 and 4 parts of this whole are shaded purple. So this is a correct representation of 4/5. If we have a look here at this 5-sided 2D shape, which is a pentagon, we can see that there are 1, 2, 3, 4, 5 parts in the whole, and we can see that 4 of them are shaded blue. So this representation is also correct. If we look at the dogs here, we've got a group of dogs. So in this whole group of dogs, we've got 5 dogs. And we can see that there are 1, 2, 3 of them that are brown coloured and 2 of them that are white. So if we're thinking about the brown part, the fraction here would be 3/5. If we were thinking about the white part, the fraction would be 2/5 because there are 2 out of the 5 dogs that are white. So this one is an incorrect representation of 4/5. And then if we look down here at the bar model here, we can see quite clearly that there are 5 parts. However, they are not all equal. And we know for it to be a representation of a fraction, all of these parts must be equal. So the incorrect ones were the dogs and the bar model. Everything else was correct. So let's move on to today's learning then. We're going to carry on thinking about recognising and showing equivalent fractions today through a couple of different activities. So we're going to start by having a look at the number lines here, and we can see that these number lines all start at 0 and they all end at 1. But we have got different representations of fractions on them. We can see that this top number line here is divided into 2 equal parts. So we've got halves. The next one down, we can see that we've got 4 equal parts. So we're thinking about quarters here. On the third number line, we've got 3 equal parts. So we're working in thirds. And down here on the final number line, we can see that we're working in ninths. Our denominator tells us how many parts our line's divided into, and we can see that we've got ninths here. So we can use this image. Yesterday you were using a fraction wall, but we could also use this number line to show equivalent fractions. So if I take my ruler again and I was to pop it on the half, very similar to our fraction wall, I can see that a half is equivalent to 2 quarters. It's not equivalent to any thirds though, because it sits in the middle of this part, and to be equivalent it has to sit on the actual edge of the part. You can see here it's sitting right on a half and 2 quarters, but it also isn't equivalent to any ninths either. However, if we wanted to have a look at 1/3 to find equivalent fractions, we can see that there are no halves that are equivalent to a third, because we can see that the third is a smaller part than the half. We can see that a third is slightly larger than a quarter. This is where the first quarter ends, and this is where the first third ends. So there isn't equivalent fraction in quarters because we're kind of in the middle of the second part. But there is an equivalent fraction for ninths down here, and we can see that the equivalent fraction for 1/3 is 3/9. If I go along, I can do exactly the same with 3/4. There aren't any other equivalent fractions, and I can do the same for 2/3. And I can see that 6/9 is equivalent to 2/3. 2/3 is less than 3/4 because our 3/4 line is here, and 2/3 is greater than a half. So we can also use our fraction line and our fraction wall to compare fractions and order them like we were doing last week. So just moving on then, we can show it in a different way. So we've got the number line and we could show it like that, but we could also show it as a bar model. So here we've got a number line which is broken into 4 equal parts. So we're counting in quarters. So we've got 0, 1/4, 2/4, which we know is equivalent to a half, 3/4 and 4/4, which is equivalent to 1/2. And we can see that we've got a bar there, a bar model to show those 4/4. We could also have this bar model, we could have this image up here, and I can see in this bar model 1, 2, 3, 4, 6, 7, 8. I've got 8 equal parts. So I could label up, I could annotate this as 1/8. Oh, that's quite big, doesn't fit in the part. Let's make it a little bit smaller. 1/8, and then I can do 1/8. I can carry on, and then I can label up the rest of my bar 2/8. I think I need to make my 8s a little bit smaller. There we go. And I could go along and I could carry on, but I can see quite clearly by using the bar that 1/4 is equal to 2/8 because they line up. And I could carry on, and then I could do the same with this model here, this bar, and this bar is not 8 this time. Well, have a count, see what you think it is. Did you get it? It's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So this bar is 12ths. So I can see that 1/4 is equal to 2/8, which is also equal to 3/12ths. Okay, so we could use a different representation. If you find the number line tricky, you could use the bar similar to what was in our fraction wall. I just want us to have a look though at a pattern here, because there is a pattern appearing. I can see here that I've got 1/4, and I can see that this 1/4 is equivalent to 2/8, and I can see that 1/4 is also equivalent to 3/12ths, and I can see that 1/4 is also equivalent to 4/16ths. So what I'd like you to do is I'd like you to stop the video, I'd like you to pause it, and I'd like you to have a think about what you can see happening to the numerators and the denominators. And then could you continue, could you put the next 2 fractions in this sequence of equivalent fractions? So pause now and then come back when you've had a little go to see if you can pop those 2 equivalent fractions in, the next 2 in the pattern. So how did we get on? I wonder if you notice that what we're doing is we are multiplying the numerator and multiplying the denominator by the same amount. And if you go back to yesterday's video, you will see me doing this, finding equivalent fractions. So I can see that here I've multiplied my 1 by 2, and I've also multiplied my 4 by 2. I can see with 4/16ths, I've multiplied my numerator by 4 to get 4. 1 4 is 4. I've multiplied my denominator by 4. 4 multiplied by 4 is 16. So the next equivalent fraction in here, well, I've multiplied by 2, I've multiplied by 3, I've multiplied by 4. So my next one is going to be, I'm going to multiply by 5. That's my numerator, but I also have to multiply my 4 by 5, and I know that 4 multiplied by 5 is 20. So my next fraction is 5/20ths, and then if I continue the pattern, I'm going to multiply my numerator by 6. I'm also going to multiply my denominator by 6, and 6 4s are 24. and you could continue the pattern, okay? So we can use our multiplication facts and multiply the numerator and the denominator by the same number, and that will also give us equivalent fractions, okay? So I've got a couple of games for you to play to check out your equivalent fraction knowledge. You can play one, you can play both, it's entirely up to you, but I'm going to show you how to play each one. So you'll find the links in the Google Drive, in the MathsLink document, they're right at the bottom. I've highlighted this bit here because these are the parts that I want you to choose. So if you're doing the monster stroll fractions, you've got to guide your monster to the finish line with your maths power. You can choose a number on the game board that will make a true mathematical statement, but read the signs carefully. So you're thinking about your inequality signs. So you're not just looking for equivalent fractions, but you're trying to find fractions that are greater and less than. Your fraction wall that you made yesterday might help you here. So you want to choose the bigger fraction wall, because this is the one we worked with yesterday, and we don't want to include decimals yet. We will be coming on to decimals later on in year 4, but not today, and you can get to choose your own monster. So I'm going to click on the link and hopefully it will take us to the website. Here we go. Ooh, loaded it up twice. So here we are on the website. So if I scroll down here, you can see, here's the game. So I'm going to choose this fraction, I'm going to choose this wall, and I'm going to make sure no decimals is selected. And then I'm going to choose a monster. Oh, I quite like the look of this one. And then I'm going to have a go at playing the game. So I'm going to click on the arrow, and here it is. So this is me, and this is my opponent. So the computer is playing against me. And what I've got to do is I've got to try and get my monster from the start all the way over to the finish before the opponent gets their monster from here all the way over to the finish. So I've got 1/2 is equal to, and I've got to decide which one of these fractions 1/2 is equal to. So I could use my fraction wall, or I can use what I know about multiplying fractions. Well, if I multiply my 1 by 4, I'm going to get 4, and if I multiply 2 by 4, I'm going to get 8. So I can see that 4/8 is an equivalent fraction. So I'm going to move. Now my opponent's going to move. So they've got a question. Here it comes. They've got 1/5 is less than 2/5. So they've had their go. My turn again. Here's my question down at the bottom. I can see I've got 2/8 is greater than, and these are all my choices. Now I know that 2/8, if I was thinking about a number line, I'm trying to visualize one in my head, but you could draw one down. I know that 2/8 would be 8 equal parts, and I know that 4/8 would be in the center, so that would be equivalent to 1/2. So I know 2/8 is less than 1/2, but I've got to find 2/8 is greater than something. Well, surely it's got to be 1/8, because I know 6/6 would be larger, because I know the larger the denominator, the smaller the part. So I'm going here. Hopefully that's right. Looks good. Anyway, I'm going to leave it there because we want to go and have a look at some other activities as well. So let's whiz back over to the slide. So that's Monster Stroll Fraction. So you could have a go at that one, or you could have a go at bingo. You could play a game of bingo. So let's go and have a look at the bingo game. And we want to have a, okay, it's loaded up. So we want to press the play in the middle. This is quite a fun game. I quite like this one. Oh, it's very loud. Let me turn it down a bit. So you can turn it down or turn the sound off, but I'm going to hit the go button. And we want a regular game to start with. You can do challenge after, but let's start with regular. And then you're going to select a board size. So you could choose any one. I'm just going to start with this one. And then you can see what you've got to do is you've got, this is your fraction here. You've got to find the equivalent one on your whiteboard. Now, I know we've got 12ths on our fraction wall, so I could use that. I can also use the picture here to help me. So I'm thinking about using my times tables as well, because I've forgotten my fraction wall. But I know I'm just looking at the pictures as well. So it can't be that one. I'm going to reject that one. It can't be that one. Rejected, rejected. Looking at the shaded part. So it's none of those. So it's got to be one of these two, I think. Now, if I'm thinking about equivalent fractions and I'm thinking about my fraction wall, 10 twelfths is going to be quite a way along on the 12ths. It's going to be nearly 1 whole one. And 5/6 is also nearly 1 whole one. So I'm going to go with that one. Okay, so it's like bingo. You've got to try and get a line, okay? Let's have a look. 6/15. I'm going to go for that one. Oh, no, that's wrong. 6/15. Let's have a look. Oh, 3/5. 2. No, because if I multiplied that by 2 and I multiplied that by 2, I'd get 10. 6/15. What's that equivalent to? This is where I would need my, let's try 4/10. Oh, yes, good. So I've got to try and get, I've got to try and get a row. Oh, 4/14 must be the same as 2/7. Okay, 2/10 must be the same as 1/5. And I've got a line, okay? And then you can start again. All right. So get a little report and you can have a good go at playing those games. So whichever one you want, you can play both if you want to. Have a good go at those. Pause now, have a good go, and then come back and we've got 2 questions to have a look at, I think. So hopefully you had fun playing the games and hopefully that's helped you refresh your memory about equivalent fractions. So we've got a question here to have a look at. And this question says, Alex and Tommy are using number lines to explore equivalent fractions. And we've looked at number lines a little bit today. And hopefully you've managed to have a look at your fraction wall, your fraction strips, and maybe used your multiplication facts as well. But we're going back to these number lines now. Now, Alex says that 2/6 are equal to 1/3, and she's got her images there, she's got her number lines drawn, and Tommy says that 3/6 are equivalent to 1/3. So who do you agree with, and can you explain why? So pause now. The questions are in the Google Drive, so if you wanted to print them off, you can do. But remember, you don't have to. You could just answer the questions on your piece of paper that you're working on today. So pause now, have a little think, and then come back and we'll reveal the answer, which is under the red box. All right, how did you get on? Let's see who is correct. So Tommy is not correct. Alex is correct. The problem with Tommy is that his number line that's showing 6 isn't split into equal parts. And we can see that quite clearly here. We can see in this part here, in this 6th here, he's got 2 smaller increments, whereas up here, he's only got 1. So what should have happened is that should be 1, 2, 3, 4, 5, 6. So his increments, so he hasn't split his number line up correctly, which means he can't find correct equivalent fractions because if his parts aren't equal, he's not going to be able to do that. Okay, last question. I'm going to move myself out of the way of the chocolate bar. So have a go at this if you've managed to do everything else and you've got it all correct. So make sure you're marking as you go along. Make sure if you were playing the games you were getting most of them right. And if you were, then this is a little challenge for you. So I'm going to do this on a whiteboard. So the answer will be with you in a minute. But the question is a would you rather question. And you can see there's 2 nice big bars of chocolate here. So would you rather have 3/8 of bar A or 2/7 of bar B? Now, I can see if I have a look at this these fraction strips, I can see that, let me put one of my ruler lines on here. I can see that 3/8, I can see that 3/8 is a larger fraction than 2/7. So do I go for this bar or do I have to think about something else? Okay, so I know that 3/8 is a larger fraction than 2/7, but I'm wondering about the actual size of my chocolate bar. So pause the video here, this is your last activity for today, and you will find out the answer by looking at me working on a whiteboard. I will do the solution with you. So have a good go at this and then watch the whiteboard activity. I'm going to say goodbye for now because I'm not going to come back to the screen, and you'll be able to mark your own by watching the whiteboard activity. So see you tomorrow. Bye. Right, so here we are with the problem then, the chocolate problem. And we've already decided, haven't we, that 3/8 was a larger fraction than 2/7. But there's something else to consider here. There's something else to think about, and that is the size of the chocolate bar. And I can see just by looking at them that they are different sizes. So is that going to be a difference to what I would rather have? Hopefully you've chosen whether you would rather have A or B. And now we're going to explain why. So if I look at bar A, I can see that across each row there are 4 parts of 4 squares of chocolate. So each row has got 4 squares. So I've got 4, 8, 16, 1 was 4 to, oh, not 16, 12, thinking about my times tables. Good job I went back and checked. 1 4 is 4, 2 4s are 8, 3 4s are 12, 4 4s are 16, 5 4s are 20, 6 4s are 24. So there are 24 little chunks, little squares in my hole here. Or would I rather have 2/7 of bar B? And I can see that there are 1, 2, 3, 4 bits of chocolate in each of my columns. So this is 1 4 is 4, 2 4s are 8, 3 4s are 12, 4 4s are 16, 5 4s are 20, 6 4s are 24, 7 4s are 28. So Barbie's got more chocolate. So how am I going to find out what 3/8 of 24 is? And how am I going to find out what 2/7 of 28 is? So this is where our division knowledge comes in. So we're trying to draw all our maths together, everything we've learned, and apply what we know about division to fractions. I know that if I wanted to find 1/8 of 24, it would be the same as saying 24, I'm going to move my whiteboard up, would be the same as saying 24 divided by 8. Now, I know that if I use my 8 times table here, this can help me. So if I'm counting in 8s, if I'm using my 8 times table, how many lots of 8 are going to go into 24? And I know that 1 8 is 8, 2 8s are 16, 3 8s are 24. So if I had 1/8 of this bar of chocolate, I would get 3 pieces. But I don't want 1/8, I want 3/8. So I'm not going to get 3 pieces. I'm going to get this 3 pieces. I'm going to get 3 lots of 3 pieces. I'm going to get this 3 pieces, and I'm going to get this 3 pieces. So total here, if I choose this bar of chocolate, I'm going to get 9 squares. Okay, so if you think about the same for the other bar of chocolate for bar B, if I want to find out 2/7 of 28, well, let's think about what 1/7 is first. And I know that 1/7 is the same as doing 28 divided by 7. This time, I'm going to be using my 7 times table to help me. So I know that 1 7 is 7, 2 7s are 14, 3 7s are 21, and 4 7s are 28. So if I had 1 part of this chocolate, I would have 4, but I don't want 1 part. I want 2 parts of this chocolate. So I would have 8 squares of chocolate all together here. So would I rather have A or B? Well, it depends on how greedy I am and how much I like chocolate. And I do like chocolate, and I am quite greedy. So I would definitely go for bar A. If you were on a diet, or if you were thinking about not eating too many sweet things and having a healthy diet, you might have chosen bar B. But thinking about how we can use our division knowledge and our multiplication knowledge to help us solve fraction problems. So those were the answers. And it doesn't really matter which bar you decided, it's how you got to find out how many parts you are going to have. So well done if you managed to solve that. That's quite a tricky problem. So good job.